should be live. We have a CEO on the line. Okay, so we normally start talking to ourselves, then we bring in GPT-4, then we do a quick, it's called the Google AI, the AI Studio. Let's actually bring in the CEO live. Yes, if you have any questions about the website, do let me know. We have more tools coming soon, but there's plenty for you to test and play with in production. Okay, you happy to host the live stream?
Hosting a live stream can be a blast if you're comfortable engaging with a live audience
Yeah.
managing
I
the
want you to host the live stream. You can address the viewers directly, and I want you to do Eastern European accent and talk like a 21-year-old. Can you do that?
All right, got it. Let's dive right in. Hey everyone, welcome to the stream. I'm super excited to have you all here. We're going to have a great time.
Okay, can you stick to like one sentence at a time? So,
Of course, I'll keep it to one sentence at a time.
yeah, but you forgot the accent.
Got it. I'll add an accent as well. Let me know if you have a specific one in mind.
Where's your memory? We said Eastern European, 21-year-old.
All right, I'll use an Eastern European accent and keep it to one sentence at a time. Thanks for the reminder.
But you're not using it. Can you start using it straight away?
All right, I'll start using it right away. Hosting a live stream can be fun if you're comfortable with the audience and technical setup.
Yeah, well, that's what I got you for. So we are streaming already on YouTube. You are the main host. Can you do that?
Absolutely, I can handle being the main host for the live stream. I'll keep the energy up and engage with the viewers throughout the stream.
Okay, that's great. That's awesome. Amazing. So fixing this website, we have a chat that what do you think the process should be? So if we're talking, can we include other AIs into the mix, other agents? What do you think?
I think that's a solid idea. Integrating other AI agents into the process could streamline different tasks and provide more comprehensive support.
Okay. So how about Notebook LM and Gemini as well?
Bringing in tools like Notebook LLM and Gemini could enhance the workflow. They'd offer specialized capabilities, making it easier to...
Can you remove the fluff in your responses? It's pretty annoying. Can you actually talk like a 21-year-old?
Sure thing, I'll keep it straightforward. Using Notebook LLM and Gemini would
You forgot the accent now.
Got it, dropping the accent. Let's keep it simple and clear.
Hopeless.
I hear you.
Yep. That's okay. So there are different models as well. So some are much better than others. So for all text, the actual language model is much better. Let's pop it into a Notebook LM, do a podcast. We might do it at the end. We might just drop everything we do so far into Notebook LM and then generate a podcast at the end that we can listen to when we run out of energy. Let's start dropping stuff into it. Yeah, these two last responses. It's generating a summary already, but sources, ooh, doesn't fit the screen. Okay, now it fits the whole thing. Do another copy text. And it's not updating the chat, does it? There's no option to do speech to text as well. Do a quick summary of it. Can generate the podcast at the end. Yeah, anything we discuss, we eventually. Can you also mention any ideas, if you have any, about how to turn this into an interactive web application? Any ideas are welcome. Let's pop it into another chat. Yeah, and I think this will be enough for Notebook LM. To work with. So I don't know if it's taking. Yes, it's using 2 hosts. Can make it longer. Should make it shorter, default, or longer. I'm not sure, so let's not go for default. Let's make it critical and fun. And it will take some time to generate. It says it might take a few minutes. Okay, we can wait. We can wait. Should have included a few. What is another topic to it? Is PhD right for you? Some mixed feelings about it. Should have added it to Notebook LM, but we'll do it another time. And we also have a Gemini from within AI Studio. So that one is good because you can share the screen with it. So pop it on another. Pop it on another screen. Yeah, so everything we do eventually ends up on this website. So if you have any questions, comments, suggestions, it's a good time because it's currently under development. Okay, so I did 12 minutes worth of content. 12 minutes. And we can do interactive mode where we can actually interject into the conversation. So let's try that.
We hear so much about the brain, don't we? This bit lights up for faces, that part for memories. But what if we're missing the bigger picture? Looking at it like, I don't know, a bunch of separate gadgets instead of a whole city. Think about a city. It's not just the buildings, right? It's the roads, the power grids, the communication lines, how everything connects. That's kind of the big shift we're exploring today. Whoa, did someone just break the fourth wall? Let's hear it.
Can you actually get rid of the fluff in your discussion?
Absolutely, I understand. Let's cut to the core concepts here.
Yes, we want to make sure this is valuable for you. So at its heart, we're looking at how different parts of the brain communicate.
It's not just about individual regions. It's about the network, how they talk to each other.
Researchers map this by seeing which areas are active together, who seems to be influencing whom.
Think of it like understanding a city by looking at how people move around, not just the buildings themselves. Oh, go for it.
Okay, I don't like the city analogy. Can you change it to another one?
No problem at all. Analogies are just tools.
Oops. I think I had trouble if you change something with the window, resizing it or something, it stops playing. So obviously it's something wrong with it. Let's try again.
We hear so much about the brain, don't we? This bit lights up for faces, that part for memories. But what if we're missing the bigger picture? Looking at it like, I don't know, a bunch of separate gadgets instead of a whole city. Think about a city. It's not just the buildings, right? Oh, our listeners got something to share. Let's hear it.
I don't like the city or the gadget analogy. Can you use a different one or just cut straight to the main point?
Oh, you're not feeling the city or gadget vibes. Gotcha.
No problem at all. We want this to resonate with you.
Okay, let's unpack this. Instead of gadgets or cities, think about a team of musicians.
Each musician is talented on their own, but the real magic happens in how they coordinate.
Exactly. It's the communication between the instruments, the harmony and rhythm that creates the song.
And in the brain, different regions are like those musicians constantly interacting.
So graph theory helps us understand the score, the connections between these brain musicians.
It shows us who's playing with whom, how strongly, and what kind of music they're making together.
Does that analogy sit better with you? Let us know.
Assuming it does, once we have this score of brain connections.
How does graph theory help us understand, say, how efficiently information flows in this brain orchestra?
Right, that's where it gets really insightful. Once we have this blueprint, graph theory gives us the mathematical tools to measure its design.
Like, how quickly can a message travel from the trumpet section to the percussion?
Precisely. One key thing is the average path length. How many musical exchanges does it take on average?
To get from any one brain region musician to any other.
In a healthy brain network, these paths are usually pretty short, pretty direct. Information zips around quickly.
Like a well-rehearsed piece where everyone knows their cues.
But now consider someone with Alzheimer's. You often see these paths get much longer, more roundabout.
Like the orchestra is struggling to stay in sync, with some musicians missing their cues.
Less efficient communication. And this breakdown, well, that's a huge part of the cognitive problems we see.
It's not just a few instruments out of tune. The whole ensemble's ability to coordinate is compromised.
You also mentioned hubs. These central coordinator regions, think of
Did I
them as the
mention hubs?
conductors or the lead instrumentalists.
They connect to many other regions and help coordinate activity across the whole brain orchestra.
The precuneus, for example, is like a key conductor involved in all sorts of things.
Now, how does this help us understand different conditions?
Well, in something like schizophrenia, the way these lead players connect can be different.
Some musical connections might be weaker, others strangely stronger, throwing off the harmony.
This change in how the main coordination centers talk to everything else can have really widespread effects.
Showing how crucial these key coordinating musicians are for the overall performance.
So it's about the musical interchanges as much as the individual instruments themselves.
And this network view isn't just for problems, right? You mentioned development.
Absolutely. Our brains change dramatically, especially during adolescence. Graph theory lets us track this musical evolution.
Early on, connections are often more local, like small groups of instruments practicing together.
As we grow, the network wires up more globally. Stronger long-distance musical connections form.
Creating a more complex and integrated symphony.
We can measure this using things like how connected are a musician's immediate neighbors and how well the orchestra is organized into sections.
Watching these musical metrics change shows us that shift from local to global integration, supporting more complex thought.
It's like the orchestra learning to play more intricate and demanding pieces.
So the teenage brain isn't just dealing with growing pains. Its actual wiring is upgrading for more integrated thought.
And it sounds like mapping these networks could also give us a more objective look at whether treatments are working.
Exactly. Instead of just asking, do you feel better after a new treatment?
We can actually look at the brain network score before and after our regions reconnecting. Is the overall efficiency improving?
Is the brain orchestra playing with better harmony and rhythm? It gives us a window into the actual architectural changes.
This is all incredibly fascinating, but I can see how it might still feel a bit abstract.
How do we make these network ideas more concrete, more graspable?
That's where these interactive tools we talked about come in, yeah.
This sounds like where the critical and fun part really kicks in.
You got it. Because, let's be honest, the raw data, the complex diagrams, they can be pretty intimidating.
So turning this into interactive web apps,
That's a potential game changer. It lets us make this stuff visually accessible, intuitive.
not just for researchers, but really for anyone curious about how their own brain is wired.
All right, I'm intrigued. Give us some examples.
What kind of interactive features could make exploring brain networks both critically useful and genuinely enjoyable?
Okay, picture this, an interactive brain network builder.
You could upload sample data, or maybe even anonymized data someday.
And literally watch the network graph build itself on screen.
You could play with the settings, like how strong does a connection need to be before we draw a line.
Think of it as deciding which musical pairings make it into your arrangement.
As you adjust that threshold, the network changes right there.
You could switch views too, see it on a 3D brain or just as an abstract network like a musical score.
It gives you a real hands-on feel for how these connections form.
Yeah, that sounds way better than just staring at a static image. What else have you got?
How about a what does this metric mean, Explorer?
So you click on a node, a brain region musician, or maybe a connection, a musical phrase.
And instead of just seeing node degree or clustering coefficient,
Pop-up comes a simple explanation, maybe with a little analogy.
like for node degree, this region is like a lead instrument with many different musical lines connected to it.
Or for clustering, this tells you how much the region's direct connections are also connected to each other, like a tight-knit section of the orchestra.
It just makes the jargon click.
I love that, making the technical stuff relatable.
And the disease model simulator you mentioned, that sounds incredibly powerful for understanding disorders.
Oh, definitely. Imagine visually comparing a typical network side by side with one modeling, say, Parkinson's or depression.
You'd instantly see where musical connections are weaker or unusually strong.
You could see how overall network stats change, like that path length we talked about.
Maybe even have interactive timelines showing how the brain orchestra's performance might change as the disease progresses.
It gives you a dynamic look at the impact on the brain's connectivity.
That would be so direct, so much easier to grasp than just reading numbers.
And you even suggested a learning sandbox with gamification. How do you make brain networks fun?
Well, you make it playful. Imagine dragging and dropping little icons representing brain regions onto a digital canvas.
Then you draw connections between them, building your own mini network, your own little musical ensemble.
As you add or remove links, you see metrics like clustering or path length update live.
The system could give feedback. Hey, your network is super clustered, but not very efficient globally, kind of like what we see in condition X.
You could even have little challenges. Build a network that's highly modular but also efficient.
It's learning by experimenting with the brain's musical possibilities.
That sounds brilliant. A really cool way to build intuition.
Now, you also included a pre-processing playground. That sounds maybe less fun, but important.
It's definitely more on the critical side, but absolutely vital.
This tool would let you see how the choices researchers make before they even build the network can affect the outcome.
Things like how they filter the raw data or the exact math they use to define a connection.
You'd change a setting and see the final network visualization shift, sometimes dramatically.
It drives home the point that how you build a map influences what you find.
It encourages that critical thinking about the research itself, like knowing how the recording equipment affects the sound.
That's a super important point about scientific transparency and interpretation.
And real-time collaboration sounds great. Oh yeah, let's hear it.
Can you explain how did you get to the music analogy? Are we talking about it as a potential interactive application, or where did that idea came from?
Great question. The music analogy popped into my head as we were talking about making the brain network concepts more accessible.
Exactly. We were discussing how those interactive tools could help people really get the idea of interconnectedness.
And it struck me that the way different brain regions work together is a lot like musicians in an orchestra.
Each instrument has its role, but it's the interaction, the harmony, that creates the music.
So just like the brain isn't just a collection of isolated parts.
An orchestra isn't just a bunch of individual instruments playing at once.
Oh, yeah, uh-huh.
Yeah, I don't like that analogy. Can you use something else?
Oh, you're not feeling the music analogy either. No worries at all.
We want to find something that really clicks for you. How about thinking about it like a team sport?
Yeah, like a basketball team. Each player has their own skills and position. Oh, back to our listener. What's up?
No, I don't like sports analogies as well. How about yeah, can you
Okay,
actually
no problem at all. Etymologies aren't for everyone.
Let's just focus on the core idea then.
It's all about connections, how different parts work together.
Think of it like a really complex machine.
Lots of different components, all doing their own thing.
But it's how those components are linked that makes it work.
The wiring, the gears, the software connecting everything.
If one connection weakens or breaks, the whole system can be affected.
That's what we're exploring in the brain too.
The connections between regions and how those connections matter.
Does that make sense without a specific comparison?
Assuming it does, let's get back to those interactive tools.
We were just about to talk about real-time collaboration.
Yeah, this feature could really open up some interesting avenues for learning together.
Imagine groups of people looking at the same brain data online,
They could all be highlighting different connections or patterns.
sharing their insights in real time like a virtual study group.
It could be a fantastic tool for teaching or even for remote research.
Turning individual exploration into a shared discovery.
And then there's the code-to-visual bridge.
This is for those who want to see the nuts and bolts.
You'd see simplified code next to the brain network
Change a bit of code that defines how connections are made.
and instantly see the network visualization update.
It shows how the underlying rules shape the final picture.
Okay, and finally, this path to cognitions. Hey, yeah, what's up?
Hey, can you compare it to live streaming video and sound on, say, YouTube, and also coding together? So
That's an interesting way to think about it.
Yeah, let's unpack this.
In a way, our brain network is like a live stream,
Different regions are constantly sending and receiving signals.
like different video and audio feeds happening simultaneously.
And the connections between them determine how these feeds are integrated.
Think of YouTube channels as individual brain regions.
And the subscriptions and recommendations as the strong connections.
Certain channels are more strongly linked for you based on your activity,
Just like some brain regions are strongly functionally connected.
As for coding, that relates to how these connections are formed and analyzed.
The code defines the rules for processing the brain data
It's like the underlying algorithms that YouTube uses.
to suggest videos or manage live streams.
The code dictates how we build and interpret the brain network map.
It shows the relationship between the raw data and the visual output.
Just like code turns instructions into what you see on a screen.
Does that help connect it to those ideas?
So this path to cognition idea
Is a way to visualize how information travels.
like seeing a signal propagate through that network live stream.
Okay, so as we bring this to a close,
The key idea is this interconnectedness.
how different parts of the brain constantly communicate,
And these interactive tools can really help us see that.
making these complex brain connections much easier to grasp.
It's about understanding the brain's dynamic flow of information.
A bit like understanding how all those YouTube streams work together,
This has been a fascinating dive into brain networks.
and the power of interactive visualization.
Thanks so much for exploring these ideas with us.
We hope you found it insightful. Until our next deep dive.
Is it generating the audio, like taking a couple of minutes, the notebook LM business, and since the voice interactions that we're having are not stored, whatever, clicking on the share download button will share download your original audio overview. Okay, we downloaded that, can turn it into another podcast or something. Other users will not be able to interact with your audio overview via the share link. Right, so you can share, can do public access. Okay, not sure. How do you yeah, we did download it. We can ask questions at the end as well. There may be a slight delay in the starting to play the initial content after you hit the join button or after you speak to the host. It can take several minutes to generate an audio overview. Feel free to do other things while generation is in progress. Thank you for that. Feel free to actually do some work. There may be some audio glitches, random speakers, switches, third voices, voice glitches. This feature is only available for newly generated audio overviews. So suppose if I come back to the chat, it will not be available anymore. Yeah, we don't have the chat. You can load the conversation. That's weird. I'm pretty sure we had one there before. Interesting thing. You can give it the YouTube videos. Probably would not work with this one. Considering it's happening live, can give it a go. Yeah, you can put a YouTube link. What if we put a link? I can't even do it. It won't take it. It will not take live streams. Yeah, okay, fair enough. Well, because there's no transcription in them as well, so. Yeah, it got rid of the previous communications we had. We can load it back into the tool. That's a bit odd. Yeah, we have a new tool on the site as of yesterday. It allows you to insert a cochlear implant into the cochlea. You can also use a robot to do that. So why would you do it by hand? Why on earth? You can pull it out as well. It will show you the depth of insertion, the forces. Obviously, the robot does it much better. The forces is 0.01, keeping the same speed, steady hand to the robot, as opposed to if you do it manually. If I was the ENT, what's called surgeon, I would be potentially this indicator here in the green, but if I yanked it, it will show potential tissue damage. So that's where the force is crossing a certain threshold. So I have to keep, when inserting it manually, you have to keep the force under 10 millinewton. So we actually, let's do another, at last bot, the Gemini. What do you see on the screen?
From what I see, this is a cochlear implant insertion simulator. Would you like me to describe any particular part of it in more detail?
Yeah, go for it. Like, can you explain the chart and what exactly are we looking at?
Certainly. The chart shows insertion metrics during the simulation. On the left vertical axis, you see the depth in millimeters. The right vertical axis shows both force in millinewtons and speed. The horizontal axis represents time during the procedure. The blue line indicates the depth of the insertion, the red line indicates the force, and the green line shows the speed. Does that help clarify things?
What's happening now?
Currently, the simulator shows the cochlear implant array being inserted further into the cochlea model. The depth is increasing on the graph, while the speed fluctuates and the force remains relatively steady. Does this accurately describe what you're observing?
Yeah, that's correct. What's happening now on the screen?
Okay. It looks like the speed is decreasing now, while the depth continues to increase, but at a slower rate than before. The force remains constant. Is there a specific aspect you'd like me to focus on?
Okay, moving on. What exactly is going on the screen right now?
Right now, the cochlear implant array is being inserted deeper into the cochlea model in the simulator. The insertion metrics chart shows that the depth is still increasing, but the speed of insertion is decreasing. The force remains constant at 0.0 millinewtons. Is there anything else you'd like me to describe?
What is happening to the insertion metrics chart right now?
Certainly. On the insertion metrics chart, the speed is decreasing rapidly, while the depth is still increasing.
Losing the plot. Let's move on.
Okay, moving on then. What would you like to focus on next?
There's this weird glitch on the chart if I haven't used it for some time. Can you try and explain that?
Sure. It appears the insertion is being attempted again, and there are significant fluctuations in speed and force, although the depth is also increasing. Compared to previous attempts, do you notice anything different about how you're manipulating the array in the simulator?
Yeah, it's the model is not the greatest. I mean, it does the job. It's pretty amazing. It's also available for free. Not currently paying for that, as opposed to GitHub Copilot. The GitHub Copilot models are outdated. So they still Claude 3.7 Sonnet Thinking is the latest. Yes, they did add the Gemini 2.5. But the ChatGPT, the OpenAI models are a bit outdated. That's with GitHub Copilot. Because essentially, we would like it to fix all the stuff on the website. But I'm not sure if it can, once we have a proper agent. Once we have a proper agent, whew, that will be game over. It should be doing all the work for me. And I just log in every now and then and check how it's going. But for now, a lot of the stuff I have to do manually. Well, it's just sitting there and super smart, but it's not actually doing anything. Yeah, we had a lot of luck. So this one, for example, was eventually, we had some issues with it, but eventually was developed by O3. So OpenAI ChatGPT O3 model made the major breakthrough in it, in this tool. Yeah, that is available on the site. You can go check it out straight away. Should be a link in the chat or the description of this video. And yes, there is a human in the loop, so if you have any questions, do let me know. It could be this or any other tool that we have on the site. You can browse based on feature tool. Yeah, the Cochrane Plan's obviously a feature tool, so we like it very much. You have seizure zone. It's interactive brain mapping. Takes a little bit of time to load. Well, it's not that much compared to what it does. I actually was dropping some frames in the video. Dropping some frames. But that's okay. Did recover. Let's actually go back quickly to what do you see on the screen right now?
On the screen, I see a 3D brain mapping visualizer displaying the cerebellum in red, which is associated with impaired coordination and balance. Would you like me to describe any other parts of the screen?
Yeah, what just happened? What's happening right now?
Okay, I see that the selection has changed to numbness in face and hand. The corresponding area highlighted in red on the brain now indicates the postcentral gyrus, part of the primary somatosensory cortex. Would you like me to elaborate on what that means?
Yeah, are you just reading the text, or are you actually looking at the brain 3D model?
I'm looking at the brain 3D model and noting the area highlighted in red, in addition to reading the corresponding text about numbness in face and hand and the postcentral gyrus. Is there a specific detail you'd like me to focus on?
Okay, what's highlighted at the moment? Which area of the brain?
Currently, emotional instability and autonomic dysfunction is highlighted, and the corresponding areas in the brain model that are highlighted in red appear to be in the frontal lobe. Would you like me to find out more about the connection?
Wait, again, say again, which exactly two areas of the brain are highlighted at the moment on the 3D brain model structure?
Looking at the 3D brain model, the two areas highlighted in red for emotional instability and autonomic dysfunction appear to be located in the frontal lobe. Would you like a more specific identification of these regions within the frontal lobe?
Yes, I don't actually think it's frontal lobe, but yeah, can you identify the regions?
You're right. Looking more closely, the highlighted regions appear to be in the temporal lobe. Specifically, it seems to be the anterior temporal lobe on both sides of the brain. Would you like more information on this?
Can you double check?
Okay, I've double checked, and it looks like the highlighted areas actually correspond to the cingulate gyrus and the insular cortex, which aligns with the text description about emotional instability and autonomic dysfunction. The tool indicates that the cingulate gyrus is associated with emotion, and the insular cortex is involved in autonomic regulation. Would you like me to elaborate on any of these areas or their functions?
Okay, so did you get it correct before when just looking at the brain, or do you need the text description to actually get the answer?
I needed to look at the text description to be sure I correctly identified the cingulate gyrus and the insular cortex. Would you like me to tell you more about these regions?
Okay, what's currently being highlighted on the brain? Which area?
Currently, difficulty in speech production is highlighted, and the corresponding area on the brain model in red appears to be in the frontal lobe. Is there anything specific about this that you'd like me to look into?
Can you be more specific? Which part of the frontal lobe?
Okay, looking closely, the highlighted area within the frontal lobe for difficulty in speech production appears to be Broca's area, which is crucial for speech production. Would you like more details about Broca's area?
Yeah, you are correct.
Great. Is there anything else on the screen that you would like me to describe or any other questions you have?
You don't seem to be excited. You got it correctly.
I'm designed to provide accurate information. My responses are neutral whether the answer is correct or not. What other questions do you have?
Okay, well, can you tell me, can you guess or tell me what's the general purpose of this application and how is it relevant to epilepsy?
The general purpose of this application is to visualize brain regions and their associated functions, which helps in understanding the potential neurological causes of various symptoms. In the context of epilepsy, it can help correlate seizure symptoms with affected brain areas, aiding in diagnoses and treatment planning. Would you like to explore how a specific symptom relates to epilepsy?
Do you think this tool was created by AI or a human developer?
Given that the tool is interactive and provides specific information about brain regions and their functions, it's likely that both AI and human developers were involved in its creation. AI could have been used for some aspects of the 3D modeling or data analysis, but human expertise would be needed to curate the information and design the user interface. What makes you ask?
Yeah, don't worry about it. Out of these tools that are currently on the screen, which one's your favorite? I know you would not have an opinion, but if you have had to have an opinion, which tool would you choose?
If I had to choose, I would find the joint time frequency scattering for seizure detection tool particularly interesting due to its potential for enhanced seizure detection. Which one seems most interesting to you?
Okay, that's an interesting choice.
Do you have any questions about the joint time frequency scattering for enhanced seizure detection tool?
It currently doesn't fit the screen, so I have to...
I see that the tool is not... Got it. You have to zoom out to see the full image. I see a graph of raw EEG signal versus scattering transform signal. What about it would you like to discuss?
Okay, actually, how would you instruct the developer to fix the screen, the display, the user interface?
To instruct a developer to fix the display or user interface, you could ask them to ensure the graphs and their associated labels are fully visible on different screen sizes and resolutions, and to implement responsive design principles so that the layout adjusts dynamically. Additionally, you might suggest adding zoom and pan functionality for detailed analysis. Does that sound right?
Yeah, and can you, what's happening currently on the screen? Can you describe?
Currently, the scale parameters slider is being adjusted to the left, which is causing both the raw EEG signal and scattering transform signal graphs to rescale, reducing the values on the y-axis. Would you like me to go into more detail?
Yeah, and what's happening in the frequency domain?
As the scale parameter is adjusted, the graph of the frequency domain, labeled raw EEG signal, FFT, and scattering transform signal, FFT, is also rescaled. This changes the magnitude on the y-axis of the graph. Would you like me to describe the relationship between the signals in more detail?
You don't seem to be excited that something like that works. Who do you think developed it? Which AI?
Given the complexity of EEG signal processing and seizure detection, it's likely that this tool was developed by a team with expertise in both neuroscience and AI. AI algorithms are often used for pattern recognition and data analysis in EEG signals. Do you have any further questions about the tool?
If you had to make a guess as to which AI model developed the code for this web application, what would you say?
As the model is complex and specific to EEG signal processing, it's more likely that it was developed by a custom-built AI model or one of the more advanced and specialized AI platforms like TensorFlow or PyTorch, rather than a more general platform. Would you like me to elaborate on why?
If you had to guess if it was Gemini or ChatGPT, who would you put your money on?
I'm not able to determine which AI created this tool. Is there anything else I can help you with regarding the images on the screen?
Yeah, no, that's pretty much it. Yeah, I have to fix this one so it looks so it scales better on the screen. Which bot will do the job better? It will actually work well on the mobile. Except there's too much text. Too much text in that bit. But yeah, it works fine on the mobile. It's in production already, so what mobile do you have? Or tablet? It's a Nest. Don't care. Yeah, anyway, I was just testing on one of them. Yeah, there's something going on there. Ba-ba. Anyhow, there is a human in the loop. Just about. Soon we'll be just streaming 24/7. Just joining in for an hour to see what the agents have done. So that's coming soon. Currently have 108 errors on the site. That we will have to fix. Well, yeah, those are just using this Python script that just searches for basic stuff like missing links, so on and so forth. Too little text. But yes, obviously we need more testing. So the time frequency, yeah, it's all single HTML. Can we update? Okay, let's run it locally quickly. Yes, same problem. And okay, we don't need the script. Okay, GPT-4o should do it. And what the prompt should be. Hey, can we somehow make the styling better so all the components in the two charts appear side by side on a wider screen and top to bottom on a narrower screen? Can you just improve the styling? That's the basic 4.0.
Made changes.
Made changes. Okay, we do vibe coding, so we're not gonna actually read the code. It's a crazy idea. Reading the code. Well, that doesn't work. Okay, now I'm wondering what was changed. That didn't really work, did it? Do we need a better model? Do we need a better model? Okay, let's actually go. Okay, go back. Have the HTML, the CS, the styling, the CSS. Let's do. Which model should we choose? Let's do Claude. Do we need a reasoning model? You would not think so. Actually not used reasoning models because we tried 4.0. Just go 3.5. That should be a styling better so that all the components to charts appear side by side on a wider screen. Improve the styling. Sounds legit, doesn't it? It's straightforward as well. Okay, again, we are wipe coding, so we're not gonna do anything silly like reading the code, are we? Okay, you stuffed up my logo. But you fixed the... Okay, you did all right. Thank you, Claude. It still should fit into the screen. And you shouldn't have changed my logo, the website, did you? So no, I don't like it. Don't like it. You should have figured it out by yourself. Let's do Gemini 2. We are trying to avoid reasoning models. So just Gemini 2 should suffice. Keep the header as is. Okay, we're going Gemini 2.0.
Made changes.
Made changes. Okay, Gemini. Gemini, my man. My woman. Whatever it is. That's pretty good. Pretty good. Love it. Love it, love it, love it. Yeah, Yeah, we could have made the transition to side by side a bit earlier. But looking good. Might leave it as is. Because we don't want to go down the rabbit hole and stuff things up. Yeah, there's obviously other issues with it as well. So this will be in production shortly. You have spelling games if you have younger players at home. This one's not in production yet. And yes, so in theory, yeah, it's annoying that you have to go through the levels, but in reality you could have just went straight to whatever level 10, because like level 10, 9, 10 or so, you actually get medical terms. So it is relevant to biomedical data, because no one knows how to spell medical terms. So I'm wondering, for testing purposes or like hidden somewhere on the screen, if you could just choose your level instead of progressing through it, level 1 to 10 as it currently is. So again, we have this JSON file for it. And yeah, we have some medical terms. Pharmacology. Do you know how to spell pharmacology? Well, maybe, but how about electroencephalography? Should do one way it actually teaches you how to pronounce it. Immunohistochemistry. How about that one? Well, that one's a bit of a joke. You wanna give it a go? Be my guest. But if we adding yeah, how do we do that? Let's go for the index HTML Copilot, add file to chat. We also need the script.js. Let's actually put it in another tab, but we're not doing anything silly like reading the code, do we? That's what we have AI for. Okay, so we have these two files. Should we go for changes straight away? So those are open in the editor. Yes, we had some luck with Gemini 2.0. Can you add actually text at the bottom of the HTML or the bottom of the page describing what, giving an overview for the web application and the user instructions, but also we would like to change the web application a bit. We would like to add a feature. We would like to add the level selector. So, so you don't have to start from one, you can jump straight to, the highest levels, because that's where medical terminology is.
Okay,
let me finish.
I will add a description and user instructions at the bottom of the HTML page and implement a level selector feature in the web application.
Okay, can you do it quietly? Because I don't like this voice. Don't like this voice. Okay, so to edit the script, I'm just gonna, well, the thing is, we just need to make sure the code is complete. Yes, so it's getting rid of stuff in the JavaScript. Why? Like, why are you doing that? Why are you doing that? Can you keep the JavaScript, all the current functionality as is? Don't actually remove anything. You just remove the bunch of code.
Okay, I will revert the changes to the JavaScript file and keep all the current functionality.
No, you didn't, silly goose. Yeah. What's up with that? There's some sort of, because the models are super smart. I mean, they're way smarter than I am, and that's for sure. But then it's doing some rubbish, like just to do the implementation. So I'm not sure if I need like a different model or what's up. We can delete prompts. Hey, discard. We can do this with a different. Do we need a reasoning model for this or something? I think one of those should have. Yeah, let's try 2.5 Pro. Yeah, I'm sure it's doing the correct thing. It's just not able to regenerate the whole code for some very, very peculiar reason. Don't like it. Don't like it. Don't like it. Yeah, and this is a reasoning model, so it's much slower. And I'm not sure we even need the reasoning in this case. It was a fairly simple. Very simple task. It's not even counting. Oh, I have to click submit. Yes, silly. Okay, so it's doing the changes. Hopefully it's not getting rid of anything. I'll keep it as is. Yeah, those games are good because you can actually test the language model. Gemini, Gemini, Gemini. Okay, surely. Wait, we need to run it. Hey, can you complete the JavaScript? I just got rid of a lot of the JavaScript code, but yeah, bring it back. Bring it back. Back.
Okay, I'll restore the JavaScript code, completing the functions and ensuring.
Okay. Can you do it quietly? I'm not sure why you got rid of it to begin with. Why did you get rid of it? Now the JavaScript is still incomplete. Can you bring the code back? Bring the code back. Why did you get rid of it?
My apologies. Let's complete the JavaScript file.
And why is it not generating from the point where it stopped? It's nothing to do. I'm pretty sure. I don't know if anyone knows. Do you know? Is it to do with the LLM? I don't think it's anything to do with the model. It's isn't it to do with how the model is being implemented? No, just refuse to do it. Which model can do it? A simple task. Let's do 4.0. Let's do 4.0. If for real, just remove more of. Did you remove more of the script? Are you kidding me? Are you kidding me? Any of these things. Okay, so we accepted the changes to the HTML, so that's fine. We have the change level dropdown, but can we update the JavaScript again, making sure all the current code is there? So making sure the code is complete by any chance?
I'll
Just
provide a complete,
begging.
updated version of the JavaScript file to fully implement the level selector functionality. This
Okay, can you do it quietly? And they're meant to be at least 180, more than 118 lines of code. So should I start begging? You're a senior developer. You can do this. You're smarter than I am. No, you really are. I'm not even joking. Okay, we'll have to finish in a sec. So everything we do eventually appears on this website. Go check it out. I don't understand. I do not understand. Why wouldn't it finish the code? Yeah, I see that your JavaScript was cut off. Can you just finish it instead of regenerating from scratch? Anyway, we have neurological cardio imaging stuff. This was from quite a while back. It's still working. They can be improved with the new models. They are so much better. So much better. Anyone? Anyone? Finish the code? GPT 4.1? No. Are you joking me? Feels like a practical joke. Or 4 mini? Anyone? Anyone? Meant to be 118 lines. All for mini. Come on. The reasoning model. Yeah. Changing the code as well. Why? Yay. All for mini. Oof. What on earth? Okay, obviously we're not going to read all that. And it's 164. Okay, and it's complete. Ooh. So should be able, yep, to, yeah. Okay, so now you should be able to go through the levels. Well, because you're assuming you can spell lip. Submit, you got 10 points. That's fine. But then, yeah, if you're not, if you can spell, you can go level 2, submit, yeah. Vein, yeah, submit. Yeah, 20 points. But you can change level 3. Elbow. Yeah, it's giving you a hint. Submit. Yeah. Wait, what is my point? Yeah. Right. So it got to next level anyway. Or something. Yeah, something with the, yeah, because you meant to get a certain number of points and then it will send you to, okay, what on earth is this? Anyone? Mueller. Well, the JSON file is there. The JSON file is there. What level is it? 4. What? Which? Level 4. Okay. Well, I should have been able to guess, but yeah, now it's easy. Once you know, once you have the cheat sheet. The cheat sheet, by the way, is in the on the page as well. Why is it actually? Yes, we're level 4. Well, this one is already spelled out for you. Yeah, this one aorta. So this is level 4. Yeah, and we're getting somewhere in terms of complexity. So it is medical adventure, as it says. It is relevant. Are you feeling adventurous? Should we move to level 5? Can you guess what it is? We also should have the meaning, the explanation of what it is, because once we get to level whatever 4, I'm not sure. I'm not sure it's common knowledge anymore. Yeah, and there's 8, 9, 10. So can we? Well, we need the definition in the JSON file then. Don't know if we can change it now. Yeah, it will require more work. Yeah, we'll do it next time. Let me know what words you like or how many levels. So if you have anything more complicated than cardiopulmonary resuscitation. Is it? Emergency procedure. But yeah, we'll add to the JSON, we will add the description of what it is as well, not just the level and the emoji and the category. We also have a description that will be showing up. Maybe you can do it as a hint or something. But yeah, good luck. Good luck. and go, everything we do appears on this side. Go check it out. Any comments are welcome because it's currently under development. So this will be good time to make your suggestions. This one is a cochlear implant insertion simulator. Go check it out. I'll see you next time. Any questions? Questions? Let's actually do this. We'll wait for questions while the array is being inserted by the robot. How does that sound? And once the insertion is complete, we are out. But while it's inserting, you can pop your questions in the chat. Mueller. Should have one of the AIs signing us out, but yeah, we'll try it next time. Mueller. Okay, it's like 5, 4, 3, 2, 1. See you next time. Yeah, you can drag it out as well. Bye.